Yeah. Okay.
Uh, because not because you are then beautiful than us, I and Rose, but because you are the age uh, spelling your name. Okay.
Okay, all right, okay. So I think the screen has been shared, and I think
Yeah,
everyone
very
can
clear.
see the screen now. Yes, I hope that is in the full screen now.
Very clear.
Okay, all right, okay. So, okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to Indonesia, all the participants from Indonesia and also from Malaysia. First of all, I would like to thank you so much to Prof. Riza again to inviting me to consider me as one of the speakers for the series of the International Lecture Share Series based on the study base of academic and base practice. And it is an amazing event, and I think it's been shared by Malaysia and Indonesia most recently, and they've been receiving a very good and positive feedback. And I think at this moment, in University Kuala Lumpur, in my campus, basically the students is already just finished the examinations, and I
Mm,
think, and this is still early in the morning, so some of them join, and some of them still coming
mm,
on the way to join. So for today, we have a very interesting topic, which is the environment, sustainability, and energy power supply trend. It is a huge topic, but nevertheless, since I came from the aviation campus, I will focusing detailing on the sustainable energy for aviation.
mhm.
Yes, my name Hazaria, like senior lecturer from University Kuala Lumpur, Malaysian Institute Aviation Technology, which is focusing on the aviation campus. Just a bit about the campus, just to see how our campus looks like. We have two campuses, one in Subang on top, and the bottom one is in the Sepang. Both of them are very close to the airport, and we are focusing on the aviations and also in the aerospace related. So we are what we call it approved training organizations by local authority, which is Civil Aviation Authority Malaysia, and also the European Aviation Safety Agency. So we are more or less a very hands-on university, a very hands-on campus, 60% theory and 60% practicals and 40% theory. Yes, again, it is a very interesting topic when we talk about the sustainability environment. There's a lots of different things that we would like to cater: the environment, the global electricity, the emission, the friendly, the naturals, recycling and such. But when we talk about the sustainability, we nevertheless will focusing on the SDG goals, right? So if we see the sustainable development goal, we can see that the number seven, affordables and clean energy, the climate change, the life on land, what we call the sustainable cities and communities. This is all related to the what we call it the sustainability related to the environment. And environment sustainability in the whole concept, we talk a lots of different things, but mostly people we talk about the tree plantations, about saving trees, about like in the emails, like we always look at the bottom part of the email and saying that never print it unless it's necessary, save trees and such, right? And we can see a lot in the universities buildings, in the government buildings, always have a indicator telling that, oh, okay, switch off when you are not using it. So all those kind of thing is rather somehow related to the environment sustainability, right? And of course, in these particular presentations, we are talking more or less focusing on the renewable energy. But we also have the with the waste conservations and waste management and also water conservations. So all of these are related to the environment sustainability. But when we talk about the renewable energy, as I was mentioning, that we'll be focusing on, we have biomass, we have geothermal, we have wind, solar. and even hydro. So this is all the type of energy resources that can be renewed that need to be further investigate and further what we call it address it in for the future usage. But when we talk about the aviation, but when we talk about the aviations, the only renewable energy that cater the aviation is solar, biojet fuels, we have hydrogens, and also we have the electric propulsion. So these are the 4 different types of renewable energy that cater the aviation industry. When we talk about the aviation's industries nowadays, we always refer to something that is green and being using the sustainable energy. So these are the concept, this are the requirements by the authority in order for the aviation industries out there for them to fly, for flying in future, green and sustainable energy. But again, for today only, I will be focusing on the sustainable aviation fuel, or we call it SAF. So this has been used by many countries and has been started since early 2005, and it has been some of the countries has been mandate to be utilize the sustainable aviation fuel, which is SAF. But what it is actually SAF? It's sustainable aviation fuels, basically a type of fuels that being defined as a renewable or being used by the waste derived materials or components or compositions. So basically, SAF is being analyzed by the ICAO, the regulatory of the aviations, and it was saying and proven that it has the carbon CO2 emissions reduction. So when we talk about SAF, it's something that being used by the waste materials, mostly waste material or renewables, alternative energy that can reduce the CO2. But let us look at the trends of the biomass, which is part of the renewable energy that currently available out there. We can see that the first generation, you can see that during all those early days, they have the corn, they have a sugar cane that always been telling that, oh, this type of biomass can produce energy that also being used in the aviations. But it is basically is a competitions between the food crops. So they are, in terms of the aviation industries, they wanted to look at it as a whole sustainable in terms of the life cycle analysis, which is the LCA. So the first generation is rather somehow is not suitable for the aviation because it's compete with the food crop. All right. And the second generation is non-food crops, and it use also waste biomass, which is we can see that in here. We can use the sugarcane bagases. We can have the wood pulp or even the switchgrass, even the waste cooking oil. This is what actually the SAF currently utilize it, but nevertheless, it is still not yet what we call it due to the demands. You know, like when you have the waste cooking oil, how many waste cooking oil that we can gather in order to cater all the aviation demands. So they come up with the third generations of the biomass, which is derived from the microalgae. They have a different type of the microalgae that can be cultivated on the non-arable land and on the even the wastewater, and it has the drawback will be the high cultivation cost. When we said that the non-arable land and also wastewater, for examples, in some Europe country, they have the wastewater from the airport and they cultivate the algae at that particular location, because you know why? And also sometimes they also cultivate the algae at the factory. because algae eats CO2. This is something that it can be countered back, and it can be a very sustainable in terms of the whole life cycle analysis. So they're eating the CO2, in the same time they can produce the biojet fuel for aviation. And the fourth one is the more or less the same like the third generation, but it's derived from the engineered algae and also from the cyanobacterial biomass. So this also something similar with the third generation, but it will improve the productivity. So all these type of generations of the biojet fuel can be used and has a very optimistic life cycle analysis, and also towards the future demands of the aviation industry. And then we have, oh, I'm sorry, I jumped too fast. Sorry for that. Oh my gosh. Sorry, yes, good job. Okay. All right. Okay. So we have the generations of the biofuels, and then we have the what is actually the advantages of the this type of biomass that can be adapted to has to be used in the biofuel for the aviations. When we talk about the aviation, everything is expensive. Everything that is very high cost, not in terms just like we wanted to buy the whole aircraft, but also towards the end of the, for example, about the maintenance. So we wanted to make sure that cost is something that is very minimal when we try to adapt something that is very new. So in here, the advantages of having this biofuel is actually it just drop-in fuel, like a normal fuel that we went to the gas stations and then we just fill it up. So no modifications to the aircraft engine will be required, and it will be something that is very beneficial to the airline operator and such. So in here, they have a lots of different types of the aviation industry that is work for the what we call it for the sustainability of the biojet fuel. All right, for examples, like we have the SAFU, Sustainable Aviation Fuel User Group, and we have the Roundtable Sustainable Biofuels, and so many under the authority surveillance in order to make sure that everything is in order with the aviation industry. All right. So in here we can see that okay. Actually, how it works, how the sustainable aviation fuel works. We can see those 5 steps that is summarized in here. The first one is that when the feedstock being collected, either is use cooking oil, the households and also the agriculture waste, and then it will be sent to the factory to convert the feedstock to the SAF. And number 3 is where the SAF being blended with the traditional jet fuel. So in here, when we say that blended, means that we are not yet 100% use the SAF for the aviation industries. As up to now, it's up to 70 to 80% only. All right, it still need to be blended with the traditional jet fuel. This is because of the first thing is the properties of the fuel itself that act as a difference to address a different composition in the aviation system. But also in terms of the demands, okay, we still not yet being able to cater the 100% usage of the fuel in the aircraft engine. And then we also have the number 4 is the distributions at the airport and into the aircraft wing. And towards the end, number 5, the lower emissions flight by using the SAF. So in here, we can see that we have the, what we call it, the 80% reduction in CO2 when we are using the SAF. So when we talk about the environment sustainability, this is actually what the industries out there, regardless of the aviations, the automotive, the marine, for examples, even railway, these type of things that basically they wanted to address actually how many percent the reductions of the CO2 can be attained in order to make sure that there will be an environment sustainability. All right, and then we have okay, right. Okay, in here we can see that when we talk about the SAF, okay, so the IKO is also working to facilitate the SAF in order to ensure that development and also deployments through their four mainstream, which is the first thing is that we need to understand that this SAF can be accepted globally and can achieve their environmental standards. And the second one is that the SAF goals, the policies, and the measures when the airline operator is using the SAF, does it match with the policies? I think if you talk about some other systems, some other industries, it's less critical compared with the aviations. In the aviation, we need to know that whenever that we introduce a new fuel for the aviation, for the engine, for example, we need to ensure that the engine is capable in understanding the whole system of the chemical composition, number one, and also it need to understand that this engine has been has an engine contract with the manufacturer, for example. They have like same like our car, for example, like when you have a new car, new engines car and such, you have the what we call it the certain duration that you have to follow. Okay, 5,000 kilometer you have to go and send to service minor, and then 10 kilometer you have to send to service major, for example. So same goes as aircraft engines. When this aircraft engine manufacturer and these introductions of the new fuels, it need to be matched in terms of the policies, so that the airline operator will not lose the engine. I mean, the contract will be void if they introduce something new that is not being approved by the authority. And then the third one, we have the capacity building and assistant. For example, that if you are introducing a new materials or new energy to the society, for example, you're not going to just, okay, this is a new one, okay, you use it. Whatever happened, I don't want to know. I did not give you any detailings on the process, on the procedures, if you encounter any problem, for example. So in here, when we talk about this renewable energy deployment, which is SAF, the capacity buildings and the assistance is very important in order to make sure that there is no what we call it contradict to what the actual implementations goals in the beginning, yeah. And the last one is the outreach and information and the best practices. I think when we talk about any different types of new energy trend, I think more or less the four mainstream of this SAF can be adapted, because we wanted to make sure that the new things being introduced can be adapt and adopt in the proper way and in the correct way. And then we have, oh, again, I'm sorry. I think I made a lots of mess regards to the presentations. I'm sorry for that. Oh my gosh. It wanted to jump directly to the end, Prof. Reza. Okay, I'm sorry. Okay, and then we have the under IKO also, if you go to the website, you can just simply go to the website under the IKO, you can see a lots of different, what we call it, the publications in order to understand more about actually what is the renewable energy playing an important roles to the aviation industries. And you can see a lots of different publication that can be addressed in terms of all the environmental sustainability. Then also we have all the publications about the methodologies on the SAF, about the feedstock cultivation, harvesting, and how it will convert from the raw material just now to SAF, and how from the SAF transportation and distribution, and how combustion in the aircraft engine itself. So all this kind of information can be seen in the website of SAF and towards the CORSIA publication. And then, yes, this is something that wanted to show that in terms of the carbon emissions, yes, when we talk about sustainable environmentals, sustainability and such, we are looking towards the carbon emissions as a general. Okay, so we can see that in here, the aircraft technology playing an important role, basically, when if we wanted to reduce the carbon emissions. We can see that from 2020 and we can reach like 2070, we can have a very, what we call it, the carbon emissions reduction. But again, aircraft technology itself will be frozen until up 2050 and will not give a tremendous carbon emission reduction unless you are using the compositions of the combustion process using a biomass, for example, or even the hydrogens towards the end. It can has a very short periods of time in order to have a carbon reduction. All right, because every single thing that come from the CO2 is from the emissions of the combustion process. Okay, and this one's also the ICAO assistant capacity building and training for the airline operator. As long as you are the member of ICAO, Malaysia and Indonesia is part of it, we are being giving an assistance and capacity building by the ICAO. And yes, there's a lots of different publication again for the best practices to investigate for the more details on the SAF. And these are the current updates of the SAF being used throughout the airports. All right, and also policies related. We can see that in here up to 57 airports already being using the SAF, and 23 policies has been adopted under the development of the SAF. And as a current moment that we are speaking, we have 34.9 billion liters of SAF has been under the agreements of reduction of the carbon emission. And they have 9 conversion process converting from the raw materials or the generations of the biofuel to the biomass to the aviation fuels. And there are more than 440K commercials flight that has been used the SAF. So imagine that the trends of the what we call it, the energy that only focusing on the aviations, but later on we can hear the Dr. Rofli talking about might be different industries, different fields. So these are more or less the map of the airport that already being used SAF. All right, and these are more or less the batches has been delivered. Starting from the beginning is a very little, and now has been increasing tremendously up to 2022. And basically, this is what we are talking about the figure infographic just now, and you can see that the correct numbers in order to understand detailing on how the deployment of the SAF to cater the sustainability environments in terms of the what we call it aviation industries. And again, when we talk about the aviation industries, it need to be certified. You cannot like only locals authority certified, then okay, we can use it. No, it need to go and follow through all the standards of the international, which is the ASTM, American Standard Testing and Materials. So we have all the certification that follow through the tedious process, all the procedures that need to be followed by them. And yes, and this one, the aviation industries basically has set 3 goals in order to address the climate's impacts. An average annual improvement in fuel efficiency 1.5% from 2009 to 2022. It might look very small, but when you talk about aviation industries, you are talking about like 100,000 pounds of gallon of fuel being used at only one flight. For example, if a destination is like from Asia to Europe, for example, this actually 1.5% is contributes a lot to the aviation industries. And we need to understand that a cap on net aviation CO2 emissions levels for the carbon neutral growth. And also we need to have having the net CO2 emission reduction by 2050 compared with the 2005. And again, these are more or less, I will share the presentation here so that you guys can read more details on the presentations, because I'm not going to read it, but to capture the very important, what we call it, numbers is very important in order for us to understand that actually what are the aviation industries out there is doing in order to have these carbon reductions, stabilize the net aviation CO2 through the carbon neutral growth, and also the net carbon, zero carbon emission for the global emission. All right, so yes, Malaysia, it was in the map in the previous slide, but actually it's just like 2 years ago, right? Where else the other peoples is doing more on those early days, but Malaysia just have it December 2021. The first time that we are using 38% of the SAF using the cooking oil. And when we talk about the understanding details, Indonesia also have activate their arm in understanding the carbon emission towards the biojet fuels, and this has been carried out by the ITB or ITB, yeah, the Institute Technology Bandung, whereby they already tested it up by using the bio after. If I'm not mistaken, they are using the palm oil. All right, to test it and to understand it, and on how this carbon recognition can impact on aircraft through different series of testing. This is something amazing. Then perhaps we can explore more details on this thing. But again, when we talk about aviation industries, we know Airbus, we know Boeing, and those two giants, what we call it, manufacturer has their own plan in order to understand and achieve the carbon emission reduction. Or for Airbus, they're using it, the terms of decarbonizations towards their implementations of what we call it, their manufacturing, and also towards their performance. And they are addressing the remaining 50% of reduction towards different things, not through what we call it, the just only for SAF, but also towards the improvement of the air traffic management. All right, the routes, the flight path, the flight plans can be having a reduction in the fuel emissions, hence also reduce in the carbon emission. And also, of course, the technology in the diagram that we shared before, the new engines and also the aircraft technologies also playing important roles in order to reduce the carbon emission other than the SAF. And also the market-based measures is also contributing in Airbus research, only 6%. But again, in this context of lecture series, we are focusing more on into the trend of the energy. Yeah, so the sustainable aviation fuel will work for the aviation industries. And for the Airbus, also they have 2035 emerge as the European target of for hydrogen commercial jet. So you can see that in here, these are more or less the initiative by the Airbus demonstrated roadmap in order to combating the carbon footprint. And towards the end, you can see that in the 2030s, the hydrogen hybrid electric aircraft will be introduced to the aviation industries. So these are another energy trends that currently is increasing in demands in terms of the research, of course, and in terms of the prototype development. Yep.
5
Again,
minutes more.
oh,
Yeah.
yes, I'm almost to the end. And also, you guys can have a look on the Airbus website and can see more details on what actually Airbus has been done, has been carried out in order to climate action plan. And yes, nevertheless, actually let us recall back why actually in the first place we are looking for new energy. Actually, why we are looking for new energy. So for us, we are here. We are developing through a new possibilities of alternative energy. But for the young generations that might be in here in this lecture series, perhaps in your time, the fossil fuel is no longer there. So what we are doing today is basically to address sooner or later the depletions of the fossil fuel. So we are looking for the renewable energy for the young generation like you guys. So explore more, be part of the researcher, be part of the university in engage into towards the new renewable energy, focusing on the trends of the possibility of new energy. So until then, just on time. Thank you so much, Professor.
Okay, good time management. If I see and if I see your talk and sharing, I remind Allahumma yarham Professor Habibi, because you talk is
Yeah.
fast before you step. You think fast before you step. It's okay lah. Ini menunjukkan smart person lah, orang cerdas lah. Good idea. Okay, some question in my email right now for you, and then but we will to go to second speaker. Usually after all the speaker sharing, we go to question answer. Therefore, for this second speaker, Pak Ruspi will be to share. Right now, do not with the song by videos for referencing because I am out of the station. Uh, I hope Pak Rufi can to continue the second speaker. Time is yours, sir.
Okay, thank you, Prof. Reza. Let me open my slide first.
Okay, very clear.
Okay, is it
Very
clear,
clear.
Prof. Reza? Yeah.
Very clear.
Okay. Okay. Prof. Reza, the host of and moderator our event today, and CEO and founder of ASEAN Lecturer Community, Dr. Azaria, Bapak Gumilang, the LLC Secretary, all lecturers, all students, and all participants in this seminar. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Alhamdulillahirrahmanirrahim, wassalatu wassalamu ala rasulillah. In this occasion, I'd like to share about environment sustainability through reverse logistic and closed loop supply chain. This is the outline of my presentation today. The first one is environment and its function, sustainability and its three pillars, sustainability development goals, and then a case study in computer industry, and then how we use reverse logistic and closed loop supply chain, and its recovery options and comparison for benefiting the environment sustainability. Okay, let me start with environment first, just to remind us about the environment. environment is defined as the total planetary inheritance and the totality of all resources, where it includes all the biotic and abiotic factors that influence each other. Biotic elements, we know that these are all living elements, and abiotic elements, those are all non-living condition and things such as air, water, land, rock, sunlight, etc. The environment performs 4 vital functions. The first one supplies resources, as just mentioned by Dr. Azaria, renewable resources, which can be used without possibility of the source becoming depleted or exhausted. And then, at the other hand, non-renewable resources, which get exhausted with extraction and use, like fossil fuel, which is will be depleted in the future. And the second function is to assimilate waste. And the third one sustains life by providing genetic and biodiversity. And the fourth one, the function of environment is provides aesthetic services like scenery and so on. Because of our the environment has limitation and also have vital functions to human life. In 1983, United Nations through Brundtland Commission defined sustainability as meeting the needs of the present without compromising the ability of future generation to meet their own needs. So we are now when we make a development, should take into consideration about our future generation. And this sustainability having 3 pillars: the economy, society, and the environment. Sometimes it is also called profit, people, and planet. So profit similar to economy, people similar to society, and planet similar to the environment. This is the 3 pillars of sustainability I just mentioned: environmental, and then social, economic. Economic, what things cost and how to make a business out of providing infrastructure, goods, and services. And then environmental, what impact those things have on nature and the earth support system, which are finite or limited. And then social, how those things serve the needs and quality of life of people and their communities. And then in order to keep sustainable for a long term, in 2015, 193 country leaders in United Nations adopted Agenda 2030, transforming our world, the 2030 Agenda for Sustainable Development. This agenda contains 17 Sustainable Development Goals, as a call to action to end poverty, protect the planet, and improve the lives and prospects of everyone everywhere. They are also as a blueprint to achieve a better and more sustainable future for all. So this is showing the sustainable development goals, from goal number 1 to goal number 17, where our discussion right now about environment sustainability relates to goal number 3, goal good health and well-being, number 6, clean water and sanitation, and then also affordable and clean energy, number 7, and then number 11, sustainable cities and communities, goal number 12, responsible consumption and production, and then the 13, climate action, the 14, life below water, and number 15, life on land. These goals are related to environment sustainability. And on this occasion, I'd like to focusing on sustainable development goals, number 12, about responsible consumption and production, where we would like more deeper in computer industry. Here is the fact in computer industry, the electronic waste, where this industry, high-tech electronic industry, is the world's largest and faster growing manufacturing industry. And then in computer productions, there are thousands toxic chemicals and electronic waste have a significant threat to human and ecological health. And in USA alone, there are 600 million computers will be rendered obsolete by the end of 2010. And of course, electronic waste has become one of the fastest growing and most toxic waste streams. And now the companies have to engage in processing used products due to the enforcement of environmental regulations by local or state or of federal governments. Also the fact we find right now the escalating deterioration of the environment. For example, diminishing raw material resources, and then overflowing waste sites and increasing levels of pollution, whether it is on land, on water, or at the air. And then the fact is hazardous or non-hazardous waste needs to be avoided or minimized to enhance environmental sustainability. This slide showing the use and faster rate of computer consumptions from year to year, but only a little of the e-waste are recycled. Most of them ended at the landfill. Therefore, it will endanger our environment, where our environment will deteriorate. Yeah. Based on the report of United Nations in 2022 regarding the Sustainable Development Goals report, we can see here that electronic waste collection rates in countries in the world having a different percentage. It shows e-waste collected and managed in an environmentally sound way. In the world, only 22.8% the percentage of e-waste collection, and the highest rate is in Europe and Northern America, almost 50%. So it is an alarming rate for us to manage the e-waste better, because the electronic waste having toxic and hazardous materials, as I mentioned before. This is the fact from extended report from United Nations in 2022 about the goal number 12, responsible consumptions and productions, where in this slide we can see there is a big difference and a big gap between e-waste, electronic waste generation, and electronic waste collection and recycling. Yeah. So this is this will be a challenge for us in the future. How the all e-waste generation can be collected and reprocessed, all of them. Yeah. We hope only minimum percent will be sent to the landfill. And regulations and legislation to protect and preserve the environment has been made by several countries, such as in European Union and also Australia. On the other hand, there is opportunity to recover and reclaim the remaining values in computer waste. So it is a good one for manufacturers to manage their supply chain, especially in reverse logistic and closed loop supply chain. So the e-waste will not endanger the environment. Yeah. This method, reverse and logistic and closed loop supply chain management, I will explain The first one is reverse logistic, reverse logistic. Also called as reverse supply chain. It is consisting of a series activities starting from collection and then reprocess it, and the last one dispose of it. At least 3 parties in this reverse supply chain or reverse logistics: collection center, recovery facilities, and demand centers. Okay. The collection centers where consumer returns used product, and then at recovery facilities, the reprocessing, remanufacturing, recycling is performed, and at demand centers, customers can buy the reprocessed products. This is the graph at the picture about reverse logistic. And then closed loop supply chain. It is a combination of forward and reverse supply chains. You can see in the picture from production facilities to demand centers and consumers, usually called as a forward supply chain, and then from customer to collection centers and back to production facilities, we call it as reverse supply chain. Therefore, we can see here there is a closed loop in the supply chain. That's why the term called closed loop supply chain. Okay. In this reverse supply chain, there are recovery options. There are some recovery options in every stage of recovery process. In forward supply chain, from raw materials come to parts fabrication, and becomes module assembly, and then becomes product assembly, and then distribute to customer. After customer using the product, the manufacturer can manage these used products by using several options. The first one is direct use or resell the used products, or the second one, repair, refurbishing, remanufacturing, and then cannibalization, recycling, or next step, incineration and landfilling. In this slide, we can see the comparison between recovery options I just mentioned. Repair, level assembly, level of disassembly to product level, and the quality requirement, restore product to working order, and resulting product, some part fixed or replaced by spares. And the next one, refurbishing, level of disassembly to module level. The quality requirements, inspect all critical modules and upgrade the specified quality level, and resulting products, some modules repair, replace, potential upgrade. And then we can see here also remanufacturing, cannibalization, and the last one is recycling. Recycling. In this recycling, we would like to reclaim the material, to reclaim the material. High for production of original parts, less for other parts. Material reuse, to produce new parts, because we reclaim the materials in these used products. By implementing this reverse logistics and closed loop supply chains, it will be beneficial for environment sustainability. We can see here the first one, saving natural resources. We conserve land and reduce the need to drill for oil and dig for minerals by making products using materials and components obtained from reprocessing rather than using virgin resources. And the second one, we can save energy, by implementing reverse logistic and closed loop supply chain. It usually takes less energy to make products from reprocessed materials and components than from virgin resources. And the third one, we can save clean air and water. Making products from reprocessed materials and components creates less air and water pollution than from virgin resources. And the fourth one, saving landfill space. When reprocessed materials and components are used to make a product, they do not go into landfill. So we don't need space to bury up the used product in the land. And the last one, saving money. It costs much less to make products from reprocessed materials and components than from virgin resources. So in this slide, we can understand some benefits when we use reverse logistic and closed loop supply chain for our environment sustainability. And that slide bring me to the last part of my presentation, my concluding remarks. First one is sustainable development requires an integrated approach that take into consideration environment concerns along with economic growth. And the second one, reverse logistic or reverse supply chain and closed loop supply chain as an integral part of managing supply chain has been expected to alleviate environmental burden and deterioration. And then the last one, the well-managed return operation will be able to reduce the depletion rate of natural resources and also to reduce the pollution rate of land, water, and air, which are substantial for environmental sustainability. I think that's all my presentation for today. Back to Prof. Reza.
Very interesting. Right now, we go to question answer. You can do short term first. Your screen. The first, I read the question for Dr. Haza. Right, Dr. Haza, are you copy me?
Yes.
Okay, ini from Dwi. Very amazing sharing, Dr. Haza. Ayum is good, smart, emotion where you presentation. Okay. I am interesting regard your breakdown topic, especially renewable energy. Right now, there is some alternative to create renewable energy as energy waters, geothermals, and nuclear. Regard nuclear, many people in Indonesia not agree. What happened in Malaysia? What your opinion regard nuclear energy? This is the question from Louis. And then from Dani, I want to ask you regard water management. Every rain with the big volume, uh, always we get banjir. Must be we fun because water is energy. What do you comment about this phenomena in Indonesia, in Malaysia too? Okay,
Sama.
this is
Okay.
the question for Pak Dr. Rusfi from Farhan. Um, thank for your good sharing, sir. I will ask about sustainable climate change. What the most impact in 10 or 20 years in the future? We must be anticipation to minimize risk. A perspective for our business, okay, about climate change. And now from Yanti, yesterday, while Prime Minister Malaysia Anwar Ibrahim sharing in leadership forum in City Corp Jakarta, there is sharing from PM regard collaboration supply chain of crude palm oil in the future. What the opportunity and challenges of supply chain in ASEAN and from ASEAN to global market? This is from Yanti. Okay. Every speaker only 2 questions because limited time for me and ask. Okay, please, Dr. Haza, 2 questions for you. Around
Okay. All right. The first,
5 to
yeah,
6
I think
minutes.
okay, a very quick one, a very fast one. All right,
Yeah.
thank you for the questions. Thank you for those who sending the questions. Yeah, the first one is related to the nuclear. Yes, when we talk about nuclear, is something that is like okay, energy, a new nuclear technology and such. But we always refer nuclear to the weapon. All right.
Mm,
So in Malaysia, we do not own or possess any controlled nuclear weapons. But
mm,
however, we do have a Malaysian nuclear agency. So this nuclear agency is under our Ministry of Science and Technology, and basically is relatively doing some research about science and about the technology and R&D related to nuclear. And when we said that nuclear is one of the energy that we would like to consider, and I don't think it need to be addressed wrongly. So I think it's very sensitive, but nevertheless, I think Malaysia and Indonesia is more or less the same. We are only focusing on the what we call it the research and development in terms of science, in terms of the medicine kind of thing, but
mm,
not in possess with any weapon, nuclear and such. All right, but
mm,
I need to rephrase that. Takut salah
mm.
faham. Okay,
Yeah.
and then the second question is related to the
Water
water
management.
management. Yes, water management. Yes, again, betul. When we talk about water management, it's not just in terms of how we use it, how we consume it, and how we control it. But when we talk about hujan, it's something that we cannot control. And most of the time in Malaysia, hujan lebat sikit sahaja. Sometimes we have banjir kilat in Kuala Lumpur. It is because of what? It's because of sometimes it's because of the the not proper managing of the sewers, for examples, or sometimes there is like a default in the system of sewer system, then kita selalu ada banjir. Akan tetapi when we talk about the water management, about the hydropower, okay, it's something that is very currently increasing in demand because yes, we have a lots of rains. Hydropower is something that is main Malaysian how we get the electricity. And also currently we are also developing the wind turbine that being put in the dam, for example, to convert the energy. We call it as a hydropower turbine, if I'm not mistaken. And in the same times also, many of the building in Malaysia, we are harvesting the rain so that we can utilize the rain to use for example, for gardening and even to use for our toilet system for flushing and such. Flushing especially, yeah, because kita basuh tangan, kita tak guna directly because sometimes they was talking about something about related to health. But normally we harvesting the rain in our campus, we harvesting the rain and we put it in the special tank and we utilize that particular raining water tadi, air hujan tadi for our flushing system in the toilet. It is not my field when we talk about the water management, but nevertheless, I think Indonesia and Malaysia, we are receiving a lot of rain, especially towards the end of our years, but monsoon kan. So meaning that how the government react and how the government policies imply on all these water management system towards the green building, for example. So these are something that we wanted to look at and we wanted to ponder upon more details on the research and the policies especially. I think that's all from me, Prof. Reza.
Very good. Very smart answer. And the next, Dr. Rusby, with around 5
Yeah.
minutes or 6 minutes.
Okay. Thanks, Prof. Reza. For the first question, about climate change. We have to avoid climate catastrophe, like the rise of sea level, and also droughts and many disasters. I think many parties should be involved in the way to manage this problem, especially in industry, and also for the community, how to reduce the emission, carbon dioxide, especially, because it leads to climate change we face at the moment. And the second one, for the collaboration of supply chain regarding palm oil, for ASEAN and global market. I think the most challenging aspect in this supply chain for palm oil, how to convince the Western countries about the productions of palm oil, because in their perspective right now, the palm oil is not a sustainable one, because some habitats harmful from these activities. Yeah, this is the important thing for this collaboration supply chain in crude palm oil. Of course, managing the forward change of this crude palm oil system will be important, as well as managing the backward change. Yeah. Like using the cooking oil into biomass fuel, as mentioned by Dr. Zahara. I think that's all, Prof. Reza.
Okay. Thank you very much. Before the closing remark, in the Zoom there is Dr. Nur, Ibu Nur from University Muslim Indonesia Makassar. Ibu Umi, apakah mau komen before closing remark? Kang Indah, apakah Ibu Nur dari University Muslim Indonesia masih adakah mau sharing cakap atau komen? Ibu Nur, if you available, but if not available, no problem, because she want to know about the new perspective. You know, Indah?
Ada di namanya tapi enggak.
Ya,
Ya.
beliau lagi dalam
Ada
itu.
dari
Oke.
Uniska sama Bu Ida.
Bu Ida juga, Bu Ida dari UPN ya, Jawa Timur.
Ratna, ya.
Ibu Ratna juga mau komen atau mau kenalan dengan Dr. Hazar dan Dr. Rusfi dari Jawa Timur. Ada masa 2-3 menit if you want to use time. Ini dari UPN, Universiti Pembangunan Nasional Jawa Timur, Dr. Ida dan ini Ibu Ratna juga. Silakan Bu, kalau mau kenalan ataupun menyampaikan kampusnya terkait ini event, silakan.
Iya.
Ibu, program studinya terkait dengan sustainable development pasti ya, bidang
Ya, supply chain tadi. Reza.
Ya, nanti Ibu bisa berkenalan dan berkomunikasi dengan Pak Rufiansah. Boleh saya beri namanya ya Pak Rufi ya, biar Jawa Timur bisa akses. Ya.
Iya. Kebetulan
kalau,
dari agribis, Pak.
Oh,
jadi terkait dengan supply chain ya menarik sekali.
Ya, nanti juga boleh berkenalan dengan Ibu Dr. Haza kalau mau naik pesawat di kampusnya banyak pesawat.
Kiri Mas, kiri lurus ya. Iya.
Baik. Thank you.
Oke, Mas,
Ibu. Ya.
Iya.
Ya, thank you very much. Closing remark from Dr. Haza, please. Dalam 2-3 menit, 3 menit.
Closing remark ya, Prof?
Yes, right.
Okay, all right. A simple one. When we talk about environmental sustainability, is something that is not just you or me. It's about us. We are the one who going to handles all these climate change impact, all the related impact when we are not taking care our environments carefully. So regardless of the industries, regardless of the area and angle that we are focusing on, and regardless of the, what we call it, the energy that we are focusing on, we are on the same mission, which is to save our environments and create an environment sustainability. So it is our obligatory, and it is our responsibles in order to make sure that our earth is safe to be lived forever, not just for another 10 or 5 years. So I hope that everyone can understand the environmental sustainability as a whole and the whole ecosystem. So we are together joining hand in protecting the environment. So go for environmental sustainability and go for the future and understand more on the future trends of the energy. Thank you, Prof.
Yes, closing remarknya macam closing remark Datuk Anwar aja ni. Very smart. Good. Okay. Because the Prime Minister Malaysia is nostalgia right now in Jakarta, ya Pak Rusdi. Okay, Pak
Yeah.
Rusdi, terima 2 minit,
Okay.
3 minit.
Okay, Professor. Yeah. My concluding remarks is we have to support the sustainability development goals, especially number 12, responsible consumption and productions. Yeah. Because it can protect and preserve our environment, yeah, by alleviating the burden and deterioration of our environment. By using river logistic and closed loop supply chain, it is the opportunities for many parties to implement it in order to reduce the depletion of natural resources, yeah, and also to reduce the pollution rate, yeah, which is it is very important or substantial for environmental sustainability. As our topic seminar today. I think that's all, Prof. Reza.
Yeah.